You all can see?
Yes, it's visible.
Sir,
Yeah.
what I'm suggesting, we have still 4-5 to go. So shut your webcam, please. Let this screen be available. Let this presentation screen be available.
Sure.
Yeah, perfect. Sir, you're visible. You're visible right now.
Now?
Now it's perfect.
So please make your camera on. Yeah. Yes, we'll be starting in the next 1 minute.
How can I remove this icon? It's coming in the front. Yeah. Thank you.
Good afternoon, everyone. Welcome to the Tiscon eDiscovery webinar number 34. Across his 5 years journey, Tiscon eDiscovery platform has reached out to over 32,000 professionals across 700 towns and cities of India. With viewers of 18 countries, Tiscon has seen legendary webinars from top professionals from all parts of the country and the globe. For today's webinar, webinar number 34, we have Mr. Ujjwal Kunte with us. Mr. Ujjwal is the founder and managing director of Durokit Engineering Services Private Limited. For the past 2 decades, he has focused on researching quality practices for construction projects across India. He is responsible for developing the 10-pointing system for quality in construction. Over to you, Mr. Ujjwal.
Thank you, Deepal. I thank Tata Steel Tiscon for giving me this opportunity to address so many professionals to this webinar. We have come across a lot of RCC structures that come up for repairs much earlier than their intended life. We also come across news items of collapses happening. So this lecture is about understanding what are the factors that impact the service life of structures, and also ways to improve the service life of RCC building. So when we talk about service life, the first question that comes to us is, how do you define service life? Is it, up to the point of collapse? Generally, service life of a building is considered only up to the point where the building comes up for major repairs. So after that also, if you do certain retrofitting measures, you can further extend the life. But the original life is from the start, when the building is completed, to the time it needs any major repairs. So what should be the life of a RCC building? Normally constructed RCC buildings have a life of 40 to 50 years. But well constructed buildings where concrete has been done with proper, due diligence to conditions of exposure, they can easily last for 80 to 100 years. But today, the science has developed so much that you can design buildings to last for 100, 200 years. There are life cycle models that are available. Then when we compare masonry buildings versus RCC buildings, we often find that masonry buildings outlast RCC buildings by many times. There are lots of examples. So we need to understand what is it in RCC buildings that, that make them so vulnerable. So we are also going to see the factors that affect the service life and ways and means to improve the service life of RCC buildings. So let us look at some of the most well-built structures. Now, if you go to Austria, there's a Mozart's birthplace. This is a building that was constructed in 1750, and it looks so new even today. Then, if you look at Holland is a country where they're short of land and they have acquired space from sea by constructing dikes. So these dikes are structures that are designed for a life of 300 years. So you can see how well they have been constructed, and they have been done with due considerations to conditions of exposure. Coming back to India, we have this BAP Swaminarayan temple, which we were party to construction in Pune. So this building was constructed, with a design life of 1,000 years, and it has got no reinforcement in entire structure. We have another famous example, which is Ram Mandir in Ayodhya, which is also being built for a service life of 1,000 years, and that also has been constructed without any use of any steel. And the biggest challenge that they had was to make it, earthquake resistant, and they have managed that. So this question comes to us that why modern RCC buildings have a shorter life. Many buildings constructed, even the RCC buildings 70, 80 years back, if you go to Mumbai on sea face, you will find them, in good condition. Whereas new buildings that are constructed much later have shown up, deterioration. So let us look at some of the possible, answers for that. One is the use of extremely high water cement ratios, as today workability requirements are high. We are doing tall buildings. There is a heavy congestion of reinforcement. We use very, very, high workability concrete, pumpable concrete. And the problem is that the buildings are constructed very quickly, you know, so not enough, care is given to the curing. So problem is the porous concrete that allows entry of degrading chemicals inside the structure. Then there's also a problem of mass scale RMC proliferation. The demand has increased by multifold. So there is very little control on the raw materials that are used in the construction today. Many a times the concrete is not designed for proper condition of exposure, something that we are going to study in detail in this particular session. And then, last but not the least, steel, quality of steel also matters. We all do physical testing. We rarely do chemical testing of steel. So let us look at what is the failure of a structure. The failure of a structure is non-performance for which it is designed, or it poses risk to occupants, or it needs repairs to allow its intended use. So failure is not a collapse. Collapse is much more than that. It is a catastrophe. So we'll look at some examples, of collapses also. This was a recent building, in Gurgaon that collapsed, and there were a couple of deaths. This particular flat was unoccupied, and then, it came up for repairs. It was being, renovated, and suddenly a portion of slab collapsed, and there were some people, dead in that. So one of the reasons is corrosion. We'll have a look at this in more detail in the subsequent session. Then this famous example, it happens not only in India but in US also. In Florida in 2021, there was this very upmarket building, Champlain Towers, which collapsed, and that left 99 people dead. And being US, there was a lot of investigation, and last year a judgment was passed. The total settlement came out to $1 billion. Imagine such thing happening in India. This is an iconic building that collapsed in Warri many years back. There were 500 people occupying that building, and they had a providential escape. Not many lives were lost because of a leaking water tank, on the rooftop. And that leaking water tank, it was, the seepage was coming through that, and there were flat slabs, and all the offices, they had false ceilings. So there was no actual visual observation of the deterioration, and one fine morning a portion of it collapsed. So if we look at these reasons for failure, one of the primary reasons that we come across is corrosion of steel. Of course, many a times we find that there's a structural deficiency, under design, what we call. And typically in under design, the structure doesn't give problems immediately. The structure will show micro cracking, deflections, and then it will deteriorate due to corrosion and other factors. Of course, there are factors like incorrect placement of reinforcement. Differential settlement has been found, as a reason for failure of many buildings, leads to major cracks, loads exceeding design loads, and poor quality concrete. So amongst this, poor quality concrete is something that we all need to focus because it is omnipresent. The other factors, like incorrect placement of reinforcement, design deficiency, they happen sometimes, but poor quality concrete is a problem that all of us need to focus on, and we will look at it in more detail. So when we look at what are the factors that affect concrete's durability, so there are factors, or when we look at durability of a structure, there are factors that affect concrete, which are primarily sulfate attack and alkali aggregate reaction. So alkali aggregate reaction is purely internal mechanism when there are certain reactive silicas that may be present in aggregates that are used in concrete, and there's a chemical reaction between that reactive silica present in aggregates and alkalis present in the concrete due to cement or sometimes water. So there is a expansive kind of a reaction, and that leads to degradation of concrete internally. So these are the photos how the degradation happens, and there's a cracking, loss of strength, and it is once it has started, there is very little you can do anything. It has to be, the care has to be taken while making the concrete. So it is advisable to test the aggregates for alkali silica reaction. So what is the prevention? Prevention is use of non-reactive aggregates, use of low alkali cements. Uh, Generally, we limit the cement content maximum up to 400 kgs because more the cement, more are the alkalis. Then it is highly recommended to use pozzolana like splash, slag, and other substitutes as a replacement of cement. Sometimes there are, alkali silica reaction inhibiting salts that can be added. And another way is that you have to since the reaction requires moisture, you can control this by protecting the subsurface concrete by various films, uh, membranes that are available, to prevent the moisture ingress. Now let us look at the factors affecting the reinforcement. Of course, corrosion of steel we are all aware of. There is a reaction between the moisture and air that goes through the capillaries, touches the steel, and how it affects is there could be a chloride. The chlorides can get in, then chlorides result in a electrochemical reaction, and there's a formation of ferric and ferrous chlorides, and it's a very expensive kind of a reaction, and it will split open the concrete. So in this diagram, you can see that the corrosion of bar, there are high stresses, there is a fracture of rebar, splitting of concrete, and corrosion is the most common reaction that affects the concrete, RCC buildings. So there is a electrochemical cell that is formed inside, and this is accentuated by carbonation. Because carbonation reduces the pH of concrete. Normally the pH of concrete is more than 12, but because of carbonation, it can come down to almost neutral, maybe 8 or 9, and that is when the passivity film that is formed, outside the rebars, that is lost, and you have, starting of the corrosive reactions. So corrosion initiators are primarily carbonation, chlorides, and sometimes stray currents. You can have these chlorides during construction. It can come if you're using if the sources could be water or aggregates, fine aggregates, or sometimes from the environment. Carbonation, all of us are aware that carbonation is a reaction where carbon dioxide gets inside and starts reacting with calcium hydroxide or lime that is present as a byproduct in concrete, and it results in formation of calcium carbonate, which is acidic and which brings down the pH of concrete. So the normal thing is that we normally test carbonation by using phenolphthalein. Wherever there's a color change that we see over here is a carbonated concrete, where there is a loss of pH, and this will lead to corrosion. We have seen chloride attack, how dangerous chloride attack can be. It also is a prime initiator of corrosion. So there is a chloride ingress, and once the chloride ingress is there, we find that there is a which we discussed. There was an electrochemical reaction, and there's continuous. It is the reaction doesn't stop once it starts. So factors that are contributing is concentration of chlorides. If there is a humidity, alternate wetting and drying. Higher temperatures are lead to a faster reaction, and of course, concrete permeability is very crucial. Use of fly ash and GGBS, they build the concrete binding capacity, so they can also help in preventing the corrosion. So let us have a quick look at the tests that we do for assessing durability. The concrete specimens, the standard tests are permeability test. This is a traditional test where the concrete specimen is put under pressure of 10 bar, and we wait till there is a continuous trickle of water, that is a constant discharge, and we use Darcy's law, K is equal to Q upon area into the length of the specimen, and we find the coefficient of permeability. So lower the coefficient of permeability, more impervious the concrete. So generally it has been found that lower water cement ratios lead to a lower permeability, and you can see here that it is 0.32 water cement ratio versus 0.65 water cement ratio. When you increase, there's a permeability of concrete has increased 100 times, 100-fold. Fortunately, now IS 516 has given a more easier test that can be easily done, which is the water penetration test of concrete, which which you should regularly do as a quality control practice. So here the concrete specimen is kept under water pressure for under 500 kPa for 72 hours, and then after 72 hours the concrete specimen is split wide open, and we measure the depth of penetration of water. The more standard says that it should be less than 25 mm, but generally for high grade concrete it is recommended that it should be less than 10 mm. If you are having very good concrete, you will generally have 3 to 4 mm penetration. Another test that these tests are recommended while doing the concrete. Okay, so this is a rapid chloride penetration test. It measures the concrete's ability to resist chloride ion penetration. We have seen that how chloride ions are very dangerous. They lead to corrosion. So they have developed a very quick method where you pass current. There's a NaCl solution at one end, and you allow the chloride ions to penetrate, and we measure the current. That is passed in 6 hours duration, and more the charge that is passed through the concrete, more is the chloride penetration inside the concrete. There are standards which says that if you are having the charge is more than 4,000 coulombs, then the chloride permeability is considered very high. 0.4 to when it is 2,000 to 4,000 it is moderate, and 1,000 to 2,000 is considered low. So we have seen that while we are doing the concrete, it is important to test the permeability of concrete and do RCPT tests, design the concrete properly so that we are able to resist the sulfate attack, chloride attack, take preventive measures against alkali aggregate reaction. But when it comes to constructed buildings, it is very, very important, to do periodic inspection, because many a times these collapses, the examples that I showed, these collapses are completely preventable. What it needs is a timely conditional assessment of buildings. Many a times the buildings are not inspected, uh, or there is a lot of cladding inside the building. Sometimes the flats are sealed; they are not available for inspection, and there's a heavy deterioration that goes unnoticed. So when we talk about conditional assessment of actual buildings, we generally adopt these measures: visual inspection, half cell potential test, chloride profiling, and UPV test to determine internal cracking. The visual inspection test is the most important test, and if you do a regular visual inspection, majority of the failures or collapses can be prevented. So what are the distress mapping? How do you do the visual inspection? Basically, we check for cracks, the signs of concrete or cover coming out, progressive increase in width of cracks. You have to track and monitor whether the length of the cracks is increasing in weeks or months. Sometimes, when the structure is really under distress, especially due to settlements, you will have problems of windows and doors not closing, movement is affected, there will be deflections, the levels of cantilevers, and if there is an identical pattern of cracks on different floors, again, it is an indication of serious distress. So what are the high risk elements? The high risk elements are always the flat slabs, because they can fail in shear. The cantilever slabs, because the reinforcement is on the top. There are many failures that have been noticed because you can't see it from the undersurface, and many a times the top is covered with heavy layer of mortar and flooring, goes unnoticed. Then I mentioned that slabs with false ceiling, claddings. So when we do a visual inspection, it is very important that we have to identify or differentiate between structural and non-structural cracks. So when we look at cracks, it is important to measure the crack width. These are some of the standard measures of checking the crack width. Scale is available. So this is a typical difference between a shrinkage crack and a structural crack. You can see the difference in the crack width. So you can see these structural cracks in slabs. And if you are able to identify these cracks early, that proverb of stitch in time saves none. Many of the serious problems can be avoided. This is in the columns, cracking in columns. So we discussed that visual inspection is the first and the foremost thing that we must do as a part of conditional assessment. And then there are certain tests that we do on that concrete. And one of the most commonly used tests is a half cell potential test. Now this test will measure whether the corrosion has initiated inside the concrete. Now one very important thing is that where there are visible signs of corrosion, where you have corrosion cracks along the line of reinforcement, this test does not add value. So this test is used where there is no visible corrosion, but there is something, the process has started inside, and you could possibly take certain corrective measures during, in course of time. These days there are a lot of paints that are available that can stop ingress of water and moisture. So you can basically delay the process of corrosion if it is detected early. So here it measures the potential difference created due to anode and cathode, and electrode. One is a reinforcement, and other half cell is the solution, copper sulfate solution. So risk of corrosion against potential difference readings, these are the standards. If you have this potential differences measured in millivolts, if it is less than 500 millivolts, sorry, if it is greater than 500 millivolts, there's a correction over there. There's a visible sign of corrosion. So you don't need a half cell for that. But if it is between 350 to 500 millivolts, there's a 95% chance of corrosion. If it is between 200 to 350 millivolts, there's a 50% chance of corrosion. And if it is less than 200 millivolts, it is 5% chance of corrosion. So you can use half cell to do contour lines. When you have a structure that is distressed, you can identify areas that are not showing visible distress, but possibly, they are likely to have started, corrosion has started inside. And it is advisable that when you do this testing, you should calibrate it by exposing certain areas. Certain rebars need to be exposed, and you need to calibrate it with the potential difference and the actual how the bar is looking like, how much corrosion has happened. So generally, how do you make use of half cell potential to take decisions? So generally, if the uh, um, uh, half cell potential is between 350 to 500 millivolts, you need to do frequent conditional assessment of building. So the next inspection due will be very frequent, maybe 3 years. If it is between 200 to 350 millivolts, it would be you may do it after 5 years. And if the potential difference is less than 200 millivolts, you can take a longer term for the next inspection. You can also apply waterproof membranes to concrete by blocking entry of moisture, and extend the life of the buildings. And you can use it to identify areas where steel needs to be exposed for retrofitting. Another common thing that we need that is done for buildings that are already constructed is profiling chlorides in the cover zone. So if the depth from the surface is 0 to 25 mm, so here what you do is you extract cores and you slice those cores 25 of 25 mm thickness, and check the percentage of chlorides in each of those slices, and you will know what is the extent of ingress of chlorides inside the concrete, whether it has reached the cover zone, and then you can take protective measures. Another test that we do is UPV of old concrete. Now, generally UPV tests, there's a code 516 that tells you, it divides the concrete of, different types of integrities. But a UPV reading of less than 2.5 certainly indicates that there is a internal deterioration of concrete and high level of cracks. A UPV reading of 2.5 to 3 kilometer will certainly indicate a micro cracking has already started inside. So you have to look for areas where there is a very, very low, pulse velocity, because once the internal cracking has happened, the pulse will scatter and you will not, get a reasonable reading. Sometimes you will not get a reading at all. So these are signs of, signs of danger, and you need to, do detailed investigation. Now, IS 456 has defined 5 conditions of exposure. We all are aware of that: mild, moderate, severe, very severe, extreme. And these are based on what kind of weathering the concrete is subjected to. So many a times the condition of exposure will be different from a substructure and different from for a superstructure. So, and you cannot, say that, we are in Pune, Bangalore or Delhi. So it could be we are not, on a sea coast. So we would be mild or moderate. If you are having, continuous, if there's a water table coming up, even in a city like Pune, you could have a severe and a very severe exposure. If there is an alternate wetting or drying, or if there is a presence of chlorides and sulfates in the soil, then the concrete has to be designed accordingly. So these are some of the durability considerations given in the IS code. So one of the minimum requirements for extending the life of building is minimum cover, and this minimum cover is often overlooked. Actually in practice it is there in the design, but it is not actually followed in practice. So greater the cover, greater is the protection given to the reinforcement, and greater is the life of the building. And what we find is that many a times the buildings, the condition of exposure is not properly defined in the DBR. So even if you are in a city like Pune, Bangalore, or a non-coastal area, you could have a severe condition of exposure where your concrete is exposed to heavy rains. If you are in Lonavala, where rains are very very heavy, so you may have to design it for a severe condition of exposure. And for each condition of exposure there is a maximum water cement ratio, minimum grade, and minimum cement content. Basically minimum, all these criteria are related to permeability of concrete, the maximum water cement ratio and minimum cement content. Because lower the water cement ratio, greater is the lower is the permeability. So sorry, lower the water cement ratio, lower is the permeability. And we need certain minimum cement paste volume to create that imperviousness. So minimum cement content is also defined. Now this is a table 4 that is very very often overlooked. It is given in IS 456. So when you do a soil investigation report, you generally you test for every meter. Apart from the index properties, you are also checking for sulfates and chlorides. Okay, so the code has already defined the minimum cement content and maximum water cement ratio for different classes of attack, and they have defined these classes of attack. Now many a times we find that there is a geotechnical investigation report, but the class of attack and the grade of concrete and the maximum water cement ratio is not taken in conjunction with the soil investigation report. If the SO3 content is between 0.5 to 1, they recommend either a sulfate resisting cement or OPC or PPC. And generally, if you are having a very high class 4 or class 5 level of attack, sulfate attack, you need to either use a sulfate resisting cement, or if there's a possibility of a chloride attack, you should replace at least 50% of cement by slag and not use SRC. So these are the things that we need to look at. So importance of geotechnical investigation is very very important. So how to improve service life of concrete? One is maintain proper clear cover, use of low water cement ratios, good curing. It has been found that good curing reduces the permeability of concrete. In earlier days they used to give a lot of importance to curing. Today, because of the speed of construction, we cannot give so much time. But 7 days of intense curing is also considered quite good, but it has to be intense and not intermittent curing. We strongly recommend use of fly ash and GGBS, for enhancing durability of concrete. Then, whenever you are having, underground concrete, substructure, you should have water-resistant coating should be given. Always beneficial. In earlier days, they used to either have Shahabad stone, protection, or sometimes bituminous coats were provided. These days, many membrane coatings are available. They should be used. And today there are also corrosion inhibitors available in concrete. Now this is very important. Testing of hardened concrete. We all test concrete for compressive strength, but it is very very important to test concrete for acid soluble concrete, acid soluble chlorides. maximum limit is already specified in IS 456, which is 0.6 kgs per meter cube. And for pre-stressed concrete, it should be 0.4 kg per meter cube. Now, many a times we are taking concrete from RMC, and RMC is generally giving certain certificates. Now, how will a client verify whether the kind of quality control that goes into the raw materials for concrete that is being supplied? So that is very difficult for a client. But the easiest thing to do is you are testing the concrete cubes, send one of the cubes to a lab and check it for acid soluble chlorides and sulfates both. And this test is very easily possible. It is not very expensive. So actually, ideally, you can do it for every pour. One very interesting, thing that happened about that Delhi collapse that I showed is that there are many buildings constructed 8 to 10 years back that have shown a lot of distress. And one of the reasons is the water that was used inside was, it was found that treated water, Delhi, because of shortage of water, the local authorities allowed treated water to be used. Now, the treated water has to be tested for chlorides and sulfates and used. And probably the RMC plants were not having that control at that point of time. And that has resulted in a lot of corrosion related problems in the structures constructed during those times. So this is something that can easily, tell you whether, the chlorides and sulfates are within the permissible limits. Then, of course, we cannot forget testing of rebars. We all are aware of bend test, but rebend test, it measures the effect of strain aging or strain hardening. So it's in effect a kind of a durability test. Generally this test comprises of bending a bar to 135 degrees, putting it in boiling water for 30 minutes, and then again further bending it to 157 degrees and checking whether there is, a cracking. So basically, it is a strain aging test. Then we should also check the steel for carbon and sulfur content. Higher carbon content and sulfur content can lead to corrosion. So how do you improve the service life of buildings by, taking care on the reinforcement that is being used? Of course, using good quality steel. There are special steels that are available, like corrosion reinforcement steels that have high amount of chromium, so that prevents corrosion. Then there are epoxy coated bars also available, but care has to be taken while using epoxy coated bars that no part of the epoxy is uh, damaged, because if certain portion of epoxy coating is damaged, that can be sometimes very dangerous because it can lead to pitting kind of corrosion. Then these are for special structures. You can go for hot dip galvanization or cathodic protection of steel. Hot dip galvanization was used for Baha'i temple. So there are some questions, like first question is that is your concrete, that you need to ask yourself, is your concrete designed for relevant condition of exposure? Okay, and how is that relevant condition of exposure arrived at? Is it based on geotechnical report? Because many a times we find that geotechnical report is on one side and actual condition of exposure considered is not in tune with the geotechnical report. Is the foundation designed to minimize differential settlement? Some portion of strata is hard and some portion is on softer strata. This is a very common problem for long-term differential settlements and cracking. Do you ask for RCPT and water penetration test when you do a mixed design or when you change the source of concrete? So these should be done as a mandatory practice. Do you check chlorides and sulfates in concrete cubes on a regular basis? So these are certain measures that you could do while when you are doing the concrete. And of course, early detection of problems by way of visual assessment and other tests like half cell and chloride profiling, that can lead to early measures which can save a lot of cost and extend the lifespan of already constructed buildings. So any questions? Thank you so much. I really regret there was a gap in between. So thank you so much. Any questions?
Sir, please open the questions tab. There are lots and lots of questions from the audience, but I think because of the limitation of time, we'll be able to take maximum 3 or 5 questions.
Okay.
So would you like me to read out some questions?
No, I'll just see. I'll just see.
Okay.
Yeah. Yeah. Actually, I'm not able to see the questions. Can you?
Amrita, can you read out the questions?
Yes, yes. So, sir, one question is regarding anti-corrosive paints. So the question is that how useful is anti-corrosive paint in protecting reinforcement? Do these kind of paints cause any debonding issues with concrete?
See, actually, I'm not an expert on this, but there are, if you are doing concrete in coastal areas, definitely you can use these paints. But the care, normally what happens is that you have to handle the reinforcement with a lot of care, because if there is a damage to any portion of the paint, then there is a potential difference that is created, and there is a likelihood of a pitting corrosion which is far worse or far dangerous than normal corrosion which is along the entire length of the reinforcement. So bonding issues are there, but you can manage that. There is not a problem. Yeah, you can use them with a lot of care.
Okay, thank you. The second question is that what are the types of waterproofing membranes used in concrete to prevent corrosion?
See, you don't use you can. There are many ways. You can either use admixtures inside the concrete, which actually reduce the porosity of the concrete, permeability of the concrete, or you can apply membranes on the surface. So there are n number of types that are available today. Bituminous membranes were earlier used, but there are polyurethanes, there are epoxy membranes, there are various membranes that are used, to prevent the basic objective is to prevent ingress of water or moisture inside the concrete. Don't allow the corrosion, oxygen inside, and that's the best way to prevent corrosion.
The next question is from Mr. Rakesh, where it says that how hot climatic conditions can cause corrosion of rebars.
How?
Hot climatic conditions can cause corrosion.
See, climatic conditions means there is carbonation that can happen everywhere. Carbon dioxide is present in the air. So if the concrete is porous, it will depassivate the concrete cover zone, and corrosion can start. Then along the sea face, there's a possibility of chlorides that can ingress of chlorides. So that can also lead to corrosion. So basically, carbonation with ingress of water and oxygen, and alternate wetting and drying. There's that normally happens in subsurface, substructures. There's alternate wetting and drying. So all these, are environmental conditions that lead to corrosion.
The next question is from Miss Poonam. She's asking that during condition assessment, if a crack is seen in RCC beam on all three sides, as if encircling beam, what could be the cause?
In an external beam, if the crack is, it depends on the location of the crack, whether, generally diagonal cracks or shear cracks. And if it's a ring shaped crack on all the three sides, it could be a torsion crack. So, you have to look at the location of the crack, basically.
Thank you. Next question is from Mr. Manoj. He's asking that why slump busters are not being used in India even now, and
Why?
are we rejecting slump busters, and are we rejecting the concrete of higher slump?
What is, I'm not aware of slum busters, but see, we can have, you can have self-compacting concrete also. There is no limit to, how much workability you can have today with the use of modern admixtures. Idea is that you have to control, so you have to check the slump retention, what you are getting at site. Maybe if it is designed for 2 hours, and check whether you are having the same slump after, if you are having more slump than what it is designed for, that means some water has been added inside the concrete, and there is a likelihood of, higher water cement ratio.
Deepak, do we have time for more questions?
I think we are out of time. I think
Okay.
we should end the webinar now. Okay, thank you
Take
everyone
one
for
last
being.
question.
Okay, one last question.
Okay. So this is just the last question. It's saying that Mr. Abhishek, what precautions would be taken if after construction we came to know that the grade of concrete is lower than the desired grade?
This is a very, very tricky question. I would put it like this. See, one is that, every RCC structure has got a lot of residual factor of safety. So, of course, you have to assess the structural part. There are two parts to it. One is the structural stability. So that has to be assessed by the structural designer. It is his prerogative. And second is that you have to check, sometimes, this lower grade of concrete, higher grade of concrete is for durability. So if it is for durability and you have found that, if it is structurally not unsafe, I would put it like this, you could take a lot of protective measures on that concrete by, various kinds of membranes, that are available to, not allow ingress of water inside. So there are, measures that you can do, and take care of the durability aspects, to a certain scale.
All right. Thank you so much, sir.
Okay, thank you everyone for being a nice audience. If you have any more questions, please feel free to write to us, and we'll be glad to help you. In
Deepak,
case
I
you
think
have any,
somebody had a question saying how can they register for the further webinars. So do you want to just help them out with that?
yeah, so we will be